I know some people still on the break. That's okay. I'm just reading the chat and just answer the questions you may have. You can look on the screen. You can see the temperature still is changing. That's alive. You see, it's the temperature is still negative 20 degrees there. Okay. It's changing. For example, you just look at this one, for example. Okay, now it's negative 21.4. Keep going. Yeah, negative 21.2, negative 21.2. So that is real time. It is at 24. I mean 0.4 again. Okay, let me read this chat. Okay, go back a little bit. Okay, what material of storage container? Technically speaking, it doesn't really matter as long as there's no contamination. The main purpose for the container actually should be two purposes. One is the protection. So you need to have something relatively stronger. Even the styrofoam should be okay. The plastic ice chest should be fine. Or sometimes just like a good quality of cardboard boxes are fine. Okay, and okay, the container, the next question, going down. Next question. I mean, normally we use the plastic one. Yeah, it's not that expensive. Sometimes we can buy it here, like $20. The styrofoam you can buy it $10, $5. The styrofoam big size and good enough for the purpose. Okay. Okay, the next one. When the matrix sample is very hygroscope, what do you suggest? Freezing samples. I leave this for Michael to answer. When should I record weight? Well, the protocol typically is saying in the field, send samples to the lab. It's about 2 kilos in our protocol. Sometimes it may have more or less. Is it necessary to record the sample weight? I leave this for study director. I don't say that. But for the lab, I'm working in the lab. I don't care too much. I don't record unless it's necessary. So I know the IR4 lab in UC Davis, in the University of California, Davis, they record all the samples, or everything. So Michigan State, our lab, we don't record. Okay, so in the field you record, that's great. So at least the common sense is if it is above like 2 kilos, that's fine. So I suggest if you record, when you receive that, you record that, put it on the scale to read. So that's what I say when you record the weight. So I don't record weight in my lab. Unless you do need to, this is something really have to. Okay, that's that one. Any other questions? Okay. Question going
Yes,
there.
I can comment on that.
Yeah, go ahead, Michael.
So in the protocol, as you said, Wayne, it will have like a listing on the number of fruit or the number of pieces of whatever you have to harvest. And it will also have a minimum weight. In most cases, you will vastly exceed the weight because you also have to meet the minimum number of samples. So we do request a minimum weight, so you should have some rough weight. The accuracy of the weight is not critical for the field. It does become critical in the lab with certain types of crops. So for example, mango. A mango has a pit inside that has to be removed. So you have to take the weight, you have to cut the fruit, remove the pit so that you know how much the weight of the pits are, how much the original weight, and then how much of the flesh is present. So that's an example. So somewhat depends on the crop, but in general, the answer is yes. You will have to take some weights on the samples, and the number of weights times you have to take the weight depends on what type of sample it is.
Thanks, Michael. Okay, well, you see on the screen, that's the temperature monitoring, the real time. You see the number keep changing, something like that. So this one is every minute there's a reading. So we can go to the database to find which time, okay, the date, time, hour, and a minute. So we can get every single one. It's continuous. Okay, let me just close this. We don't need to see this. Okay, close that.
There's still some other questions in the chat box.
Oh, okay. Let me close that now. A little bit further. Material storage. You use dry ice for transportation, dry ice for grinding. Well, for transportation, if your location is not too far from the lab, you do not have to use dry ice. You can drive there, you freeze your sample, then put in the cooler and have the temperature monitor in there, put the data log there. You do not have to, but when you ship through the carriers, like FedEx or something, yes, you do need the dry ice. The wet ice, like the ice pack, is not good. It won't last. So when you grind the sample, yes, you do need the dry ice. Yes. That's the question a little bit. Let me go one more up. Cannot purchase dry ice to grind. That's a good question. If you do not have dry ice, we need to figure that out, what you can do. Because if, look on the screen, if your sample is chopping by this kind of a powerful tool, if you don't have dry ice, you can't do the work. You are cooking the sample. Okay, after you grind it for 5 or 10 minutes, it's gonna be the soap. So no, it doesn't work. You have to use dry ice, or liquid nitrogen should be fine. So other question here, how long the sample of fruit, vegetables kept in the cooler prior to grinding? Not in the cooler. In the cooler is for short-term shipping. For example, if you ship from the field, your field is half an hour away. You put in the cooler, you freeze it first. Okay, it will be negative 20 degrees. You put the ice pack in there, and you ship the sample to the lab. That's fine. So you don't keep sample in the cooler. Okay, that's not a storage. That's just for short-term transportation. So once the sample is received in the lab, they should be in the freezer immediately. Of course, we went through the process. They need to record all the details, write all the forms, and put in the freezer. So you don't keep in the cooler. If we say this cooler, or for example, freezer, how long before you grind the sample? Now here's back to the question now, the sample integrity. If your freezer is really good, it's consistently negative 20 degrees, you can grind anytime. Typically within IR4, within my lab, it's about half a year. So it could be immediately received in the lab, you grind it right away. Or the longest time could be like a half a year. So half a year later, sometimes maybe a little bit long, won't be that long. So grind sample, put in the sample bottles. Let me put those pictures back here. Okay. So yeah, okay. When you have the sample bag, you grind the sample, you put in the sample bottles like that. Okay. So it's typically about half a year, the longest. So it depends. And you make sure your freezer is always negative 20 degrees. Okay, it doesn't matter. This is just a short term or long term. It should be always negative 20 degrees or lower. Okay, so in this case, you can grind anytime. If your freezer is fluctuating, the temperature is fluctuating, it's better to wait the sample to wait until you are ready for analysis. Then you grind it. Because once you grind that, then the sample, it's all mixed. All the bacterial reaction, enzymatic reactions going on. So it's much faster degradation for pesticides. So in this case, actually, we can use this as an example. The reaction rate, for example, K, okay, equals the rate. Actually, we should use the rate. It's better than K. So this is chemistry and also other things. Okay, let me just do a quick one. So we do the calculation from scientific point, why the temperature is important, why we need to do that. Okay. So the reaction rate, okay, the rate, if there's no enzymatic reaction, okay, rate is the chemical reaction. That's a chem reaction. Okay. So if you have enzymatic reaction, bacterial reaction, that will be very fast. I have some paper to show to see what's going on. So if your sample is like, for example, mango, if a mango itself, it's not a ground, so the pesticides most often should be on the surface or somewhere in there, then the enzymatic reaction and bacterial reaction is much slower. But a chemical reaction is very simple. So let's say chemical reaction, this rate equals, I'm just talking about a chemical, equals what? Equals the K, which is the reaction constant, times the concentration of this chemical, say this chemical A. So that's clear enough. This is typically a first order reaction. So we know concentration A, we don't want this to be changed. Okay, so the only thing is the rate depends on this K, which is constant. So what is the constant? How we calculate this K? So the K equals another constant. This is chemistry. You can do this for every reaction. So we call that, what doesn't matter. We call that A or C or whatever. That doesn't matter. Oh, we put a small a there. This is a constant that depends on the reaction. This one you will not be able to change it because this is this reaction. This difenoconazole will go down, This A will not change. You cannot change that. Okay? This is Mother Nature. Then times E to the power of the energy, which we call that the delta energy, okay, which is the energy difference or energy, divided by RT. T is absolute temperature. So the energy here, this is also Mother Nature. You cannot make any change. So the only change is what? Is this T. That's the only change is this T. The R is gas constant. So if you know any reaction, you pretty much can do this calculation, see how fast the reaction is. Then you know the half-life, you can calculate the half-life. That will be log 2, I believe, divided by the K. I don't remember exactly the half-life, T half. I believe this is, I don't remember, I think it's K. Okay, so now everything is constant except this T. This is chemistry now. So yes, depends on a lot of constants here, this A constant and the E constant up there. But T is most important because that's the only thing you can control based on chemical reaction. And you can calculate that. You can simply calculate the difference, the T difference, from negative 20 degrees through let's say I was in Thailand this time. I don't remember which time that was. I think that was April. Outside is 30 degrees. For example, in the lab, maybe a little bit cooler. So if you go from there, so the T delta T difference is 50. Then you put in there, you will calculate the half-life. It wouldn't be how many days. It will be how many hours. So how many hours, if you don't monitor the temperature, your sample will be no good because after, for example, 5 hours, your concentration will drop to half. Another 5 hours, it will drop to another half. So basically more than 60% of the residue is gone. So that's another way. This is a chemistry, okay? I'm not going to go too much to that. We can do that calculation later. But it depends on the reaction because we got a constant there. Okay.
I think the main point for practical point is that you're putting some type of ice, usually a wet ice or an ice pack, in with the ice chest that you're using to transport the samples from the field to the laboratory. And so you're already decreasing the temperature and extending the time that you're able to have from harvest until putting it in the normal freezer. We generally say a maximum of 12 hours.
Okay. Yeah.
There's some other questions in the chat box, Wayne.
Okay, it's later or before. Let's say how important is oil?
There's a question before that by Sri. It says, when the matrix sample is very hygroscopic, how do you suggest us in the tropic to weigh the frozen sample? If we wait until it reaches room temperature, the weight still goes up and the samples get wet when we should record the weight.
Oh, okay. I thought it was the field weight. You should do that immediately while it's frozen. So this is talking in the lab.
Yeah, I would say actually you should be, if you want to wait in the lab, for example, the most critical situation in which you really need to wait in the lab is if you receive a sample from somebody else and you have a doubt about the weight, you would want to weigh that, and you would do that before you put that in the freezer. In addition, if you have a sample like I described, like mango, in which you have to remove the pit, you should remove the pit and do all those weights before you put them in the freezer. Because as you say, once you freeze it, number one, it's very difficult to get the pit out, and number two, as you describe, you will have moisture form on the outside of the fruit, and you form a puddle, and that's not good because you're losing a lot of the residues. The only other time you're weighing, only on the next time you're weighing, is when you're weighing the sample for extraction, and at that point, it's already been ground and it's totally dry. As you see in the picture on the screen, it looks like a powder or like a very fine granule. If you see a paste, you know you haven't done a good job grinding.
Thanks, Michael. Yeah, that's a good point. Yeah. Well, if you can do it, you should do that before you freeze that. But if it is like in the lab, you already see the frozen samples, so don't wait, and you wait immediately to the work. Same thing as when you have samples to the extraction. You weigh 10 grams of samples, don't wait until it warm up to the room temperature. When it's frozen, do it. Okay, don't wait. That's a similar situation. Doesn't matter you get the big the bag of sample or you have the frozen sample you weigh. So weigh it immediately. Okay, how important to find out the order of reaction? At this point, yeah, thanks, Sashi. I don't think we need to find out the chemistry behind what we are doing, because we know the pesticide companies have done a lot of work on that. So what we do, they have the longer, bigger picture. Put it there. They like everything out on the desk already. We know we are just a portion. We are part of that. So what we do, we work our portion, make sure the sample is frozen. It's negative 20 degrees, so everything should be good. So it is important, but that's not our job. The Sunil, okay, how long pesticides were not significantly reduced if it is keeping, okay. If you keep the samples at negative 20 degrees in the freezer, this is what we always ask ourselves, how long your samples are still good. This depends on the stability test. So overall, I give you the time and date, overall 2 years. Okay, if your sample is longer than 2 years, you need to really ask the company, the pesticide company, it is good or it is not good. Unless they know the chemical is very, very stable, that could be like I mentioned yesterday, like a paraquat. You put in the plastic bottle, put in the freezer, it will last 10 years. Okay. For some chemicals, like they degrade very fast within like 14 days, and you get the half-life even under negative 20, then you also need to talk to the company. The company will give you the warning. So my experience is minus 20 degrees, 2 years, unless there's special requirement. So normally we work within 1 year, so that's not what we need to concern. So as long you need to concern is the freezer. Make sure your freezer is negative 20 degrees. And also another thing is we have the storage sample. So storage stability sample. You spike the similar concentration, and within the same period of time, you analyze your sample. The recovery can indicate how stable the chemical is. So that's another way to tell your residue is good or not. So I would say keep it shorter than 2 years, you are good.
Okay, Wayne, so Dr. Sunil has updated his question. He says, I mean to say vegetable sample or fruit sample. I think what he means is the whole unground sample. And I think the response is the same, unless you have other.
Yes, it's the same. If it's unground sample, it's better than ground sample. I just mentioned, I put it on the screen. Okay, this is only chemical reaction. If you grind the sample, because it got a lot of juice coming out, and the protection, the wax of the fruit protection will be gone, so enzymatic reaction will go up dramatically. So still the same. I put 2 years there. Still the same.
Yeah.
The temperature
important thing
is key.
The important thing is that you have some ground sample to set up storage stability.
Correct. That's the worst scenario. Yes. Yeah. Oh, the sun is coming out. Great. Bright. Okay, let's resume. We see on the screen now here. This is the ground sample using robot coupe, and you will see, as Michael mentioned, this is all powder. Okay, so these are good. If you see something like that, it's just like a dry powder. It's good because you have dry ice there. Okay, so that is good one. And if you ran similar grinding in your lab, you should see similar thing like this. Okay, you don't see any big particles. You don't see anything like a cooked soap. That's not good. Okay, and even on the side is the powder. So this is good. I give you an example. Okay, depends on the size of this bowl, and also depends on the sample size people give you. Okay, Michael mentioned that if it is like a mango, you need 12 fruits, you will get 10 kilo of samples. Then for sure, this kind of a grinder is not big enough. Okay, so this is typically what happened. This is in Ghana, we did that. So we did the multiple batches. We put everything in another stainless steel bowl there. And after then, we put together and just keep mixing. This is exactly what's happening. So unfortunately, it happens once in a while because if we need to meet requirement, the sample size, how many kilos, and how many fruits, and certain kind of different requirements, we will get bigger sample size. So this will happen in your lab once in a while. So it depends on the sample, depends on the requirements. Okay. Well, you could have something much bigger, whole bar like this. This one is this one's huge, probably 50 liters. Of course, if it is 50 liters, you put everything there. That's perfect. Okay. You do good job. The only thing is you have to use a lot of dry ice and a lot of time to clean up this. So you do not have to buy this kind of grinder, but if you have this, super good. Even they give you like a 10-kilo sample, you can put it one time to grind. And of course, you will waste a lot of dry ice. So if you are working in the field, please talk to the lab, please talk to the study director, make sure you get the good size, but not oversized sample to the lab. Because I work in the lab, this big sized sample really is a big burden to the lab. A lot of cost, a lot of time, but we have to grind every single sample like this, every single fruit like this. That's big pain. Okay. Let's look some pictures I took when I visit different labs. And you will see this lab has another way to do the work. Okay, they do have a robot coop, but because the fruit is like this, it's frozen fruit, it's very difficult to handle in the robot coop because it break the blades. Okay, it happened once in a while. When I was in Colombia, I can show you the picture. Do I have the picture with me? The blades is broken. I'm probably still in my phone. I can show that. The blade is broken because we keep grinding like that. So what they do, they shred the sample here first. Okay, they put a sample there. This is shredder with dry ice, and you will see this is not a powder. You will see that this is just like streams going down. Okay. So let's look the next picture, which is to look in this bowl what happened there in the lab. Okay, now this is something. You see, this is coming from shredder, like that. This is with dry ice. You still see the smoke coming out there. This is with dry ice. This is good. Now you put this one back in robot coop. You grind the second time. And it will make very beautiful sample, actually. This is exactly what's happening. So this is she's putting some samples, shredded samples, because you have to put all the shredded sample in the plastic bag, freeze it, before you can grind them in one grind. Okay, so this next slide is the final product. That's very good. Okay, so you can see that this is after shredding. You have sample, you shred into streams, then you use the robot coop to do that. You waste quite a lot of dry ice, but your sample's really, really good. So you put the C samples in the freezer. That part is good, super good. So I like that. This happen, well, it depends on the sample, depends on how you do the work. Sometimes your lab may not have this kind of a shredder to do, but this is another way. This will keep your robot coop last longer. Okay. The next slide is different one. Let's look at different one. I think this is a mango. And you will see this is a big sized, this is sample in the sample bag. Okay. And this is, after remove the pits inside, the stone inside, and you will see this is there. Okay, now you put all the samples back in here in the big bowl of this robot coupe, and this is huge size. You put everything there. It's only one grinding, so it's just like about more than 5 kilos, I believe. So you put the dry ice in there. Okay, you should put normally in this case it's 1-to-1 ratio, and you close the lid. You grind that. It just at very beginning, just you see the dry ice coming out. Okay, so then after this grinding, final product is like that. It is really good. Okay, so when we are talking about grinding, of course, this is key part. Make sure it's all frozen. You have enough dry ice. So that's important. Of course, right after that, you need to have the record to show you have sample, you grind the sample this way, you need to have the form, you need to have the chain of custody where the sample will be going to. Okay, so that's this part. I'm not going to put the form here, but you should have that. So which is chain of custody form. Now you have the one big sample you can take in different bottles, and that's called a SAP sample. So you will have some SAP samples later. Okay. So now you have one big sample. Now you can have multiple SAP samples. Okay. So you put it in the freezer. That's write everything down in the chain of custody. Okay. We're gonna talk about the standard reference material. The protocol. This is a copy of IFO protocol, and you will see this azoxystrobin here. Okay, azoxystrobin. So you need to get the GLP standard to do the work. Okay, so this is a requirement. The question is, if you don't have GLP standard, can you still work? The answer is no. You must have GLP standard. Otherwise, the agencies, JMPR will not accept. Sometimes if this, for example, this chemical needs internal standard or other material, let's say we call that short IS internal standard, I.S. Okay, and this kind of a material is very difficult to get, and it's very difficult to get the GLP standard. So in this case, can you do the work? My answer is it depends. I don't prefer that way, but if you get approval from study director or study director get approval from the registrants, the government agencies, or some people, you may go ahead do it. So that makes things a little bit complicated, but it's not the lab decision. So if you do not have the GLP standard, always talk to the study director regarding your standards. Otherwise, your work may not be acceptable. So it must be GLP standard. Okay, let's look at something. I just put 1 or 2 slides there to tell this is a COA certificate of analysis. And you will see the most important part, what I see most important part is GLP. Do they put a GLP there? It doesn't matter. This is 20 CFR 58 FDA GLP, or this is 40 CFR 160 EPA GLP, or OECD GLP. As long as they put the GLP there, in this case, they put the EPA, FIFLA, Good Laboratory Practice Standard, and this is 40 CFR 160. This is EPA GLP. So they sign here and date here, and that's good enough for you to go. Okay, of course you will have a lot of other things. You will have the I don't think. Oh yeah, it's out of the air. We will have the lab ID. We also have the ID for each standard. It's easier for you to work in the lab. For example, in this case is okay, standard 1, 2, 3. Okay, you need to put the received date there. Who received there? But it's above there, the sky and the slides. Okay, so always check, make sure you have the right lot number or something, because we need to keep this one because it's the identification to connect to the company's database, and they did some work there. And GOP statement is always the number one thing you need to make sure it's there. Okay, if it is not there, your work will be very difficult to go ahead. So make sure this is always there, the GOP statement. GOP certified standard. GOP. As long as they say this is under GOP, in compliance with GOP for the CFR 160, 20 CFR 50, as long as they use these words in the COA, Certificate of Analysis, you are good to go. Of course, sometimes you don't get the original. You have the true copy. Okay, that's fine. Okay, so that's fine. Okay, that's sometimes you do not receive the standards again. You only receive the recertification. This is an example. So this is a diquat, for example. Diquat, as I mentioned, is very stable. It's a salt, and it's very toxic stuff. It's the herbicide. I think it's about 5% of the herbicide market. It's quite big use, actually. Yeah. Paraquat, diquat. Some countries ban the use these compounds because they're very toxic. I know China and some countries ban this because this is the first pesticides for suiciding. So, yeah, this is one of them. This is the paraquat, diquat, paraquat. This is diquat. Paraquat is number one. So, for example, this is the original COA, Certificate of Analysis. We received this on the state here, and then we give the number 297. Okay, we have all the information there. Okay, expiration date, and this is going to expire. This is expired 2012. Then later, they don't give you the standard again. They only give you a recertificate. Okay, recertification. Okay, it's the same standard you put in the freezer. As long as you put in the same condition as they say, they will put something there to say where you should put your standard. Typically, is in the dark in refrigerator. So in this case, we want to make sure you have the right lot number. This is the same. This is ASJ10013-3. So it's exactly the same. They give you that, so you can continue use that. That means your expiration date extended another 5 years. So make sure make sure you have the GOP statement. If there's no GOP there, it's not good. And now if you read down here, it says GOP down there. It says GOP down there. And the same thing, GOP here. And you will see multiple places talking about GLP. So it's good. So both of them are good. So even your sample, your standard expired, you still can use that based on the new recertification. So this is how we work. And sometimes this is happening quite often, like a diquat, paraquat. This is very stable chemical that can last years. So, and typically what they do is they just need to recertify. Okay. Of course, solutions, you have to discard them, but the standard, the pure standard, you can keep using. Okay. So this is very important. Make sure it's GOP, otherwise it won't work. Okay. So after we have that, then we have a lot of records to show how you prepared the standards. For those labs I trained, I give you my forms, and I went through a lot of things there. I'm not going to go to the details. I'm just using this as example. You will see those forms. You will see all the records. You receive that, how you prepare that, and track all the use of the standard. So every single one, you also need to archive that. Okay, so that's another big training side for this thing. I put it on the side. That's not for our today because our level, some of people in the audience is very high GOP experience. Some of it is quite new. So we just bring somewhere in the middle. So if you need a training and when the travel ban is lifted, everything's okay, I will go to your lab and we'll do the more training on this thing. What I need to do, keep going on, which is talking about the labels. Well, Michael mentioned yesterday, a lot of labs have been doing this long enough and are used to do the way they work. And this is something we need to make sure everything's following the requirements. For example, if you have a solution prepared, what's the minimum requirement? This is good practice for ISO, for GOP, and for other different requirement, different things. So, for example, if we prepare a solution or a reagent, so first of all, we need to name there. Okay, we need to put names of what it is there. Okay, so and what's the condition? I mean, the storage condition, because some of them could be very sensitive. Some of them could be okay if, like, you put acetonitrile. As long as you keep it closed, they put in on the shelf, it should be next to 2 years, no problem. But once you take it out, you need to put this label on. This is acetonitrile, okay? Don't use the abbreviation. It's better to use write everything and say this is acetonitrile, for example. Some people use ACN, but that's okay. If you have SOP, if you put something ACN, that's fine. Okay, so you put the requirement there. So in this case, it's ambient. Sometimes people put it, just say A. That means ambient. That's fine. As long as you have SOP, you know what to do. That's fine. Okay, so what's the concentration? In this case, is pure solvent. You just need to write the solvent. If this is a solution, okay, what's the concentration? You need to put it there. Okay, so the date prepared or date opened, you need to write down exactly by whom. Okay, you put the initial there. So, for example, my initial, I put a W, J, that's my initial. Yeah. And also the expiration date. Everything expires. You need to mandatory to set up the expiration date there. Okay. You have a SOP, for example, if it is a solvent like this, most likely the solvent bottle will have the expiration date. If not, you need to have an SOP to design to give a date there. So in our case, typically for the solvent, we give 2 years. It depends when you open that 2 years. So you put it there. Okay, for example, 2 years, then today is 8/12. If I open that 8/12, I minus one more day, put 2 years there, that's 2022. Okay, whatever. Then today's date, I open 8/12, 2020. Well, I have to say my SOP, because in the US, we use this format for date. We use month, day, and year. And in your situation, may be different. Okay, some places maybe year, month, day. Some places maybe day, year, month. It's okay as long as you have SOP to say that, or you write something exactly right. For example, this one to minimize the confusion, you can put 11. Put the letter there, AUG. That means August, and put 2020 there. So nobody will take this wrong. But it just takes a little bit longer to write. That's fine. So it's better to have a label like this. Then you put it on there, you know what to do. Okay, so this is the requirement. Okay, for any container, for anything, you should have the minimum requirement are these. Okay, you should have. Let me erase these too many. You should have the minimum requirement here. Let me just check one by one. So you should have the name. You should have the storage condition. You should have the concentration. You should have the date prepared or date opened or whatever the activity is, by whom, and the expiration date. This is a minimum requirement. Sometimes you may have a little bit more. So this is necessary to have everything there. Here's a question. Dr. Neil put a question there. How long can we store standard if it is acetone, hexane, 1 to 9 solvent? You say acetonitrile could be better, longer. Maybe I say in a different way to your question. I meant here for the solvent acetonitrile itself, the shelf time is typically much longer because it's a pure solvent. It's not for the solution you prepared. Okay, so that's a different thing. So if you prepare a solution, depends on the chemical, depends on your SOP, how you assign this expiration date. So we know, for example, acetonitrile, even some table salt like sodium chloride. So what do you think of sodium chloride, when the sodium chloride will expire? Some people say 10 years, some people say 100 years. Okay, that's table salt. What can go wrong? Yeah, you can go wrong. It can absorb some water. It could be contaminated. So basically, you need to assign a date. So in this case, it depends on the chemical. So what I say, if you are talking about a standard solution in acetonitrile hexane, so in this case, acetonitrile hexane is very volatile. You need to set it very short rather than 2 years, 3 years. So I would say probably like 1 month or sometime is long enough for this purpose, even though you put in the freezer, unless it's like a highly concentrated. So it depends on your SOP in this case. So my answer is yes, depends, but I would say it should be shorter. So these are the minimum requirement for every single container in your lab. You put it there. You should have those information. Okay. Otherwise, there will be a finding, and that will be quite a confusion. Actually, I did make a mistake. That was 20-some years ago. We just take a bottle there, put a name there, and we made a mistake and just messed up the whole batch of the sample. Yeah, it happened. Yeah, to myself. That was more than 20 years ago. Okay. You do not have to type everything like this. Do not have to. Handwriting is okay. But the requirement is make sure your handwriting is legible. People can read. Try the best to write necessary information. If your lab use ACN as acetonitrile, okay, use ACN. If your lab did not define that, write the whole thing, just say acetonitrile. Don't use ACN because it's going to confuse. There could be other things as well. Okay, and also the same thing for the dates. If your date, for example, in my lab, I write this way, everyone understands, and most American will read it in the same way. But in Europe, they will read a different way, or in other countries, they will read different. Especially if you don't write 2020, you write 20 or something. If it is not 20, if it is like several years ago, you put a 12 there. That's very confusion. Lot of them, because that could be anything. Could be year, month, day. But in the US, we pretty much know this is year, okay? And this is all month. That's no problem. So it depends on your SOP. So in order to minimize this, as I just mentioned, to make it easier, so we will say this is 11, and this is AUG, and this is, you put it 4-digit will be better than 2-digit. Now 2-digit is fine if you write this format. Everyone knows that. Okay. So yeah, that's how you do the work. This is for both reagents and solvents and the standard. Okay. So sometimes, okay, let's just go back to this question. How about I use I pour out some solvent out of the bottle, then your shelf time will be much shorter. So it's better to keep in the original bottle, because most likely you will see the expiration date there. And that saves time and makes it easier. If you transfer somewhere else, you have to put a label there, write all those things, and the expiration date will change. And this is for the all solvent, for all solution. I just mentioned that. I just say that one more time. So you need to have the proper labels. We should have the identity. What is it? What's the name? What's the chemical? So what's the name there? And what's the concentration there? If it is solution, what's the solvent? Okay, and the storage requirement. Okay, who did that? And the expiration date. This is a minimum requirement. It should for everything. Okay, that's for that. The next slide. Let's look this one. This slide is exactly the same thing we do in my lab. This is just like you go to the bench, you take a picture. Okay, somebody's working on that. You see the centrifuge tubes here. He's working on this. And you will see these are the something, this is a mixed solvent here. This is acetonitrile and water, and 50-50. And you see, this is the label we use in my lab. If you don't circle, don't put something there, and something's wrong. So this person did that on this day, and you will see he made a mistake writing down here, and he did put a note there. This is by whom and which date made the mistake, and which reason. That's a typo because it simply did that. And you will see the same thing for this one there. It's the same thing, and same thing for that. And even, of course, those bottles are original bottles. We don't look. That's fine. And you will see the label somewhere here, and even something behind that, handwriting is there, it's okay. And same thing here. So we spend a lot of time put those labels there, and it is necessary. And this is a GOP requirement. Okay, so that's mostly we talked about all those requirements for solvent, for standards, how you do that. Then you will have the paperwork there to keep the records. Okay, and everything. Then you sign and date. For example, today's date is August 12, 2020. Then that's your original records. You put it in your file, put it in your package. Okay, you do all those things. Okay, so any questions so far? Let me read the chat box. How long do we still? Okay, I answered that. Okay, yes, that's answered. Okay, that's good. Okay, we still have a little bit time. We can talk about the QA form, or we can do. Okay, we have time. We can go back to our questions. We had some questions there. Let's see. Okay, the QA inspection here. Okay, let's do the questions. At the very beginning of the presentation, we had some questions. Let's just quickly go through that. It's very simple. Okay, the first question is, which of the following requirement is not true? It says not true for laboratory SOP to comply with GOP. Okay, So we have A, B, C, D, and E. Okay, so your SOP here, do you need the testing facility management to sign? So this one is true or false? So a lot of people put a D there. Correct. Yes, you do need the signature. Okay, to approve that, you do need to have it immediately accessible, available. You do need to review that. Typically in my lab is every year we have the form to review. Okay, you do not describe anything about a QA. Okay, because QA is totally separated. Okay, yes, you do need to perform, you do need to put a non-maintenance there. So the correct answer is D is the correct answer, which is not supposed to be true for GLP. Okay, good. Looks like everyone is doing correctly. The next question, okay, EPA GLP experimental termination date is which one? We talked about those dates. So this is experimental termination date. In our lab report, we put it on there. The final report will be there. Okay, I saw first answer, couple of answers now. A. So the date, experimental, this termination date is the last data collected. This is the correct answer. So what is this date? This date is the study completion date. Okay, and once this is signed simultaneously, it expected this way, everything should be archived immediately. Should be, well, within a certain period of time. That means no more data. So basically, these two should be almost the same. Okay, so that should be the one. So how about the last sample disposed? Based on our IR4 protocol, what we do that. We normally keep the sample 1 year after submission, maximum to 5 years. So that's how we do, dispose our samples. Okay, so this is typical what we do. So you need to get approval from the study director. Okay, so how about what ASR is signed? What ASR stands for is Laboratory Summary Report, which is the lab report. So this has nothing to do with any of these dates. That means the lab is down. Okay, so let's go back to the next question, which is exactly the same thing. We talk about study completion date. So, of course, we just mentioned that. Now this one, this is the experimental. It should be study director signs on the final report. So this is study director will put it there. So we don't do that. If you are the study director, you know that. So it should be this one. Okay. And let's do the next one. Okay. This one will be multiple selections. So let's say A, B, C, D, E down here. Which one is required GOP by GOP? For example, this is EPA work, and we do the pesticides registration. So do we need to do GLP? Yes, you have to do GLP if it is in the EPA area. Yes, you do. How about the contaminants? So let's say PFAS is a contaminant. You monitor the PFAS. Right now, PFAS is a new emerging contaminant in the U.S. because a long time ago we used it for That's like government requirement for firefighting. So typically in the airport, actually Michigan is the biggest number contamination site found in the U.S. It does not mean it's highest contamination. They found how many sites. That's the biggest one. So for all contaminants required monitoring required by EPA, it should be GLP. So when we submit a grant, we do the work on that. We have to do GLP on this, on the PFAS work. Okay. And how about the food additives? Yes. Food additives is still. And how about the marketing work? The marketing work, we do not have to. Okay. And how about the safety study for drug? Well, this is beyond what we need to say because this is the FDA work. So yes, that part, yes, of course. Okay. Any questions so far before we go to the checklist? Because we let me pull out our schedule thing. Okay, do you want to keep? No, I don't need to keep that. I do believe it's here. Oops, where's my? Okay, here. It's here. Make it maximized. So we finished the presentation here. So next is the QA checklist. Any questions so far? If any question, type in the chat box so we can answer the questions. So, okay, well, while we are waiting, let me just get things ready for this. Okay, we still have a little bit time. So let's just go through, let me use this, okay. Let's just go through the checklist, and this is typically, we will be using almost every single study, depends on where the position you are in the lab. So we will see the lab in-life inspection. Sometimes we call that, make a little bit smaller. Okay. We will see, we call that critical phase. Critical phase inspection. Okay. We do know that in the field they have a similar thing, but we are talking about the analytical, which is the lab. Okay. So we do know yesterday we had similar form. We have the study title, we have lab ID, we have the inspection date. These are for QAs. Then the next is the contact person in the lab, which typically we call that LRD, which is the lab director. It stands for, this is not a GOP term. This is the IR4 term. We call that laboratory research director. The same thing if you are in the field, just simply change this to F. That means a field research director. Then there will be a name here, an address, phone number, etc., etc. Okay. Okay. Let's go back. Let me remove that. Where's that? Here. Close that. Okay. Then will be a bigger one. This person higher level, the boss or the management. Then there will be a QA there. Who is the QA? Okay. Do the inspection. And also, if it's related to the study, of course, each study will be there. You will send this report to the study director, make sure this is the right one. I mean, the right thing did in the lab. And again, this is similar format. We will see this is, you will see, put it there. Some of them is very important. Some of them is not required, but it's important to the study, not required by GLP. So the ID, we will see that. This is lab ID. Then, oops, let me just go a little bit above here. So first of all, the most important thing, is it any SOP there? I mean, the protocol there for this work? Yes, we know that. It's always there. It should be there. And we should put all things together. Do you have the amendment there or the documentation? So typically you're going to put a yes for that there. Okay. Then you have all those SOP related there. And do you have any modification on the validation or the method? Do you see the approval? So basically, before you do the lab, before you do the real sample, analyze the sample, you have to validate the method. We call that method validation. Okay. And without the method validation, you can't do anything. So every single study, you have to do the method validation. Before you do the work, you need to get approval from the study director. And again, we see this kind of a word, approval from the study director. Okay, this is important. Okay. And again and again, you will see this as well. You will see approval from the study director, communicated with study director. So which we said yesterday, how many times? Well, I counted it more than 12 times. Somebody may count it more than that. I think it's 14, 15 times in the protocol, in the IR4 format of protocol. So that means how important to talk to the study director. So we will see, do you have the SOP there? Is it or the general practice? For example, you do the LC-MS analysis. Do you follow the SOP? Your SOP may have very specific steps. Step 1, do this. Step 2, do this. And the QA will check that. Sometimes you make it a more rubber band type. It's more flexible. You can do this. You can do that. It's the same thing, but at least that's scientific valid. That's fine. So here's the thing, and this is probably when I visit the lab, half of the lab, this is check no. Why? Yes, SOP is available, but it's not immediately available. It's not immediately accessible. Most likely will be in the lab director's office. Okay, and in this case, okay, if lab director is not there or put it somewhere, you don't have SOP available. So, well, it depends. So my recommendation is print a copy, put in the lab. So everyone has the access immediately to your SOP. And also put the number, the control number on each of the SOPs. So you are controlling these versions. That's always because you have one copy. It's easy to control because it's one person to control that. But you have multiple location, multiple copies. You have to put it there. Make sure this is controlled because always this is a living document. It's changing all the time. Okay. Yeah, there's deviations available there, and of course, when you do the lab, make sure you have adequate trained people. So this trained means several things. It means your scientific training, you have the degree, and you have training on this machine. You did that. Okay, I've gone to the training through with the GC, with Agilent, HPLC with Waters, mass spec with APCX. You have that there. And also you need to show your GLP training, like this one, like other ones, you can show that. You have to put it there. And for the GLP training, you say, okay, I did GLP training 20 years ago. It doesn't count. You have to be refreshed once in a while. So, for example, typically it's about 3 years we do that refresh. Okay, so this is all included in the training part. Okay, then you put all those things there, check. And well, based on this, what do you think? You think this is how the inspector is to look at your work, and where this is based on the requirement, or this is based on some guidance, or this is based on some scientific knowledge or requirement. And you will see this is all based on the requirement, based on the GOP requirement. You see, put out all those stars there, asterisks there. It's all the GOP requirement. You have to be there. You have to talk to the study director. You have to get approval from the study director. You have to have the SOP available. So this is GOP requirement. So that gives you overall what you expect from GOP, from the inspector, from EPA about the GOP requirement in your lab. Okay, then about the equipment. Even though this is one of two check boxes there, this is a whole bunch of work. Is your instrument is calibrated? Is it standardized? Okay, so how this is maintained? Okay, now we maintain. We mentioned that. I always say, well, you're gonna have to have specific people for this specific instrument. So this LCMS is assigned, is responsible. That's for chemist A. Then this GC is for the analyst B. You have to get exactly to one people. And also you say the maintenance. This is the routine, non-routine, and if it is routine, and what's the interval? Typically, is it every 3 months? It's every year. And logbook is always there. I know that's a good thing. That's an interesting thing. I went to all the labs. Most labs have good logbooks there. That's good. However, the logbook is quite clean. So basically, you did not write down detailed information like what Michael mentioned yesterday. You go to your balance log, and you will see the log is 3 months ago. I'm quite sure you used the balance in between, okay? So you need to write down all the necessary information there. Depends on your SOP. Some of them may be very, very detailed. Some of them may be only a certain portion. So, but at least you need to capture your work, the activity you did in the lab. For example, in my lab, we used to do every single weigh-in, we put on a balance log. So you weigh a sample, you put it there, this sample weighed on this balance, and what's the observed number. So that catches everything. So balance log is just like so big, and it's keep archiving. It's getting bigger and bigger because that's everything there. And some of them right now is getting better now because it will send to your database. You send to your LIMS system. That's better. That makes things a little bit easier. People can look at. But that opens the door to another thing, which is electronic data keeping. So that's later. We will touch a little bit about that. We talked about the samples today, and these are the things they will check. So let's see what the QA will look and what we covered. Okay, so the sample is according to everything. It should be uniquely identified. So that means you have to have every single number should have a unique number. You don't want to put the unique number long name. Okay, this is from field A. Okay, so for example, this is from California, and this is the sample is mango, and this is the sample A, and this you don't want to have so long. You want to shorten that. Okay, this is sample 1, 2, 3, 4, 5, and another one is treated sample 1, 2, 3, 4, 6. Okay, so and this number will be unique and corresponding to which sample. So you're gonna have to connect them. Okay, per protocol and per SOP. So we have both of them there. We just mentioned today. And do you see the sample ID there? Now, this sample ID does not necessarily mean when you work in that centrifuge tube, put such a long one. It could be a shorter one. But for any other thing, for example, you have a sample in the freezer, you should have the proper identification for that sample. Okay, so for the sample container, for all the containers, remember we went through that. We need to have a lot of them. We need to have system, ID, all those things. Okay, let's go a little bit down here. The proper storage, that means a lot of things. That means the sample could store in the freezer, how long, and that thing. So it should have the documentation, which is chain of custody. Okay, the sample on January 1st moved from, okay, at 9 a.m. this morning, moved from freezer 1 to the lab. Okay, I move something to the grinding. Okay, 9:15, I move to freezer 2. Okay, January the 2nd, the chemist, C, take the sample out and do the extraction. And that's 10 a.m. Then 10:30, he puts the sample back to freezer D. Then keep going on. It should have very detailed number. Why we need to do that? Because we have the temperature. We know, first we know where it goes, who handles that, and also we know how good the sample is. So the temperature monitoring is very, very important. And you will see this put the asterisk there. That means this is a GOP requirement. You have to do that. Sample processing, extraction, we will talk tomorrow. So everything should be recorded. We will talk about that and what kind of documentation we will have. Do the rest of them processing, weighing. Well, in this case, this is SEP sample. This is not the field sample. But anyways, if you weigh the field sample, you need to have a system, have all the forms to record. Okay. How about the sample during the prep? Is anything going wrong? So you need to have the record. So basically what you see from this page is everything is documentation. It's everything you did, you write on the piece of paper, people can see what you did, and did you do it correctly? Okay, any questions so far? Okay, checkbox is quite empty. Okay, now we just spent about 5 minutes talking about this, which is about 10 minutes ago. Okay, talk about the reagents, solvents, solutions. So what's the necessary information should be there? We already put it there, okay? We need to know the identification for everything. We need to know the concentration, storage condition, expiration date, who did that. Okay, you handwrite that is good, but all the information should be there. Okay, and all those things is SOP, method, required, or this is method. Sometimes if you change in a different way, people will question how good that is. For example, if your method says you need to prepare your standard daily, do you have to do that? Some people will say, no, my standard is stable enough. I can do that, yeah, every week. And I tested that, it's stable. Well, if it is like that, you will get no here. Well, it does not mean you are wrong. Okay, you will get no here, but you need to explain why. And people will go back to check your data, make sure this is the right thing. So my suggestion is, if you do that, you can. I always do that, because a lot of method, because the lab settings are different. A lot of them, they have some people just do the work, they move on the next, and they don't go back. It's daily. It's like a preparation of the standards, like their working solution. In this case, yes, that's fine. But in my lab, in the IR4 lab at Michigan, what we do is one person started from the beginning to the end, finishing their sample analysis, finishing the report. In this case, you know you did right. You know the chemical, the pesticide is stable. It's fine. So you need to provide the data showing you do not have to do that. So in this case, QA or your lab director, will check no. You did not follow, but you need to have documentation to show you did that correctly. So the same thing, this is the same as what we talk about there. So we treat reagent, solvent, solution, and standards, all materials the same way. We need to have the identity. We need to have concentration. We need to have date prepared by. This one is not necessarily prepared by because if it's solvent, it's not prepared by. Okay, but you can say who opened the bottle. Okay, and the storage condition, which is there, expiration date. The only difference is if you have something because it's not prepared. So that is the only difference. But in this case, we don't say it's prepared for the solvents, for the reagents. What we say is you open. Okay, so that's fine. You put in the same label. That's fine. Okay. So typically the good thing is here's another question. Do you discard all expired standards? So do you discard them? Okay. So this is a big question. So my answer is no. You don't discard them. You need to keep them, archive them for the standard, not solution. There, okay. I'm talking about the standard. You don't discard standard. You need to archive them. You need to keep them. For the solution, yes, you can discard. So this can be discarded. Okay. So that's important because this is the main thing. We know that this is very high concentration. It won't go bad immediately. And also, this is also the way to check you did a good job or not. So you may buy some standard from somewhere, and if the quality is not good, they still can track to see what's going on. But solution is you prepared in the lab, you may discard. Okay, so you may, let's say, may be disposed or discarded. Okay, so this, no, you keep. For the standard itself, you keep. Difficult to write. Okay, so, well, if it is expired, you need to have a different strategy or different SOP to handle your expired standards. Okay, so that is this part. We pretty much went through all of them here. So the next is we will talk about recording the data. We will talk about how you do the lab. So pretty much that's common sense, and this is also, well, the GOP required. So basically, it should be the permanent ink or the records, okay? And it should be entry should be dated, and it should be signed or initialed. So once you printed out something, you write some entries and sign and date, and that's called the raw data. Okay, so that is like that. Then you need to, if any change there, well, we will talk about this tomorrow. Okay, if we do any work, we make a mistake. A lot of times, I will say 99% chance is the typo. You typed it wrong, you write something wrong, because when most people is just copy paste, same as I do. I copy paste. Let's say there's a form there, even the data form, copy paste, change something, print it out. So sometimes something you forgot, sometimes you did not pay attention to. So that's something. So in this case, anything wrong, you need to keep the original. You don't change any original. You just need to cross it out. For example, I write it wrong, raw data. Cross it out, write any reason. So this is a wrong entry. You put a W, wrong, entry E. Okay, and in this case, well, because you have the initial, or in this case, I put my initial there. So sometimes some people's name is WE. Of course, you put a date there. Today is 12 August 2020. Okay. So in order to make this easier, and sometimes it's a correction, so we put a circle there. Same we say this is data or whatever the data this is. We write it on the correct number, whatever. Difficult to write data. Okay, so this is the general practice. We will talk about this tomorrow. So you need to explain why. WE means I typed it wrong. It's a wrong entry. And the date and signed. So I dated and signed. So that's good. For any electronic data, it has to be validated. It has to be make sure this is the right person and make sure it's verified, because you can always change, and when you print it out, you really don't know what's going on there. Okay, let's go to that's typically, well, it's almost the time now. That's interesting. So then we will see the findings there. Then QA will say, okay, finding A is, okay, you don't have SOP for your GC. Finding, okay, then you put the number there, keep going on. Okay, so after that, it's going to sign down here. The QA needs to sign, the QA, and put today's day there. That will be 12 August 2020. Okay, and sent to the study director, sent to the lab director, or whoever is handling this, whoever is going to be responding. Then the lab director typically will respond. So A, you put it there, you put the respond there. Okay, this is corrected. Okay, corrected, or something you need to write down. You do not have to agree with QA, but you need to address. So, okay, B, you say, okay, something's wrong. No, this is correct. We did right. You can explain. The most likely, if QA is reading your stuff, I'm sure QA has a reason. So basically, you must address that. 99% is something you did not follow what's supposed to do, even though this is correct. Okay, is there anything you have to take action if something is wrong? Yes, you do have to. You do write down here what is the action. And of course, sometimes the space is not enough. Typically, they give you additional space here. You keep going, and you sign and date. That's it. So that's the in-life form for lab in-life, or call that critical phase. It's already 8:40. We still have 10 minutes for the questions. Any questions so far? And tomorrow we will, let me go back to this, day 4. Tomorrow we will talk about extraction, analysis, and all the data. Then we will do the ASR checklist. Okay. Okay, please put your questions in the chat box so we will have time to answer your question now. If not, I will email you back. That's good. Let me just show you right now. Finally, this is outside. finally. Yeah, it was dark at the very beginning. Okay, it's 8:41 a.m. New York time here. Okay, any questions? We still have a little bit time to answer the questions. If not, I will, give the time back to Michael. Maybe Michael can put some comments or something.
Okay, Wayne. Yeah, I'm still
Yeah.
here.
Oh, okay.
So again, thank you for today's presentation.
Thank
I did
you.
have some questions about what you plan on covering tomorrow.
Yes.
So I see that you have a section on sample extraction and instrumental analysis. And so
Yes.
for sample extraction, I hope you will go through an example of your form and how you track the sample through the steps. So I think that's an important factor.
Okay. I will add that. I did not have that
Yeah.
on my slides. I can add that. That's easy. Add something there. Yes, I will. Yeah.
Also, to the group, I see many of you have put your name and email. Thank you. As I sent out an email this morning, we will plan to have some type of certificate along with this training. And the way we will determine who gets the certificate is based on who actually is participating in the meeting. We are determining who is participating in the meeting by having your name and email in the chat box. So if you want to get credit for this and get a certificate, if you haven't already done it, please put your name and email into the chat box. We do have some additional questions about plastic containers.
Okay, that's here. Okay, let me read that. Due to the plastic container, this we should get some plastic. I don't think so. The question is due to either storage in plastic container or somehow we get some plasticizer in GCMS background. This will be a problem and how to avoid. So the first one is this will be a problem. I don't think this will be a problem. Okay. Yes, there could be something. But if we use GCMS, LCMS, even other GC instruments, I don't think this will be a problem. And we use plastic anyways, first of all. It's used everywhere. And also our sample bags, IR4 sample bags, in the bag is the plastic liner. So yes, we will see the plastic there. There's no way we can totally avoid. And I don't think plastic will affect. There's one chemical, I forgot which name, may be a little bit affected by plastic. And in this case, you're going to have to use control as the reference to see how much the contamination could be for that purpose, for the background. So far, I don't think the plastic will be issue. And some labs even use the plastic jars, bottles, or Ziploc bags to maintain the samples in there. So no, unless this is like a volatile, it will react with plastic, and the pesticides company will give you the warning, give you the instruction how to do that. So plastic should not be the problem based on my experience.
Yeah, I had a few comments related to that. So in general, I agree with what you're saying, Wayne. There have been some instances that I've heard of with problems with plastic. Also, in many parts of the world, it's not common to grind with dry ice. So if you have a situation where you're taking a fresh sample, you're grinding it in either like a blender or you're grinding it in a mortar and pestle, and then you're storing a macerate, a wet macerate in a plastic container, there can be transfer of plasticizers. But under the systems that we use with grinding with dry ice, there's not really that type of interaction between the container and the sample. So that what the situation that you're referring to might possibly be in a situation where there's a different type of interaction or different type of contact between the sample and the plastic container that you're using.
Okay, there's another question. It says, referring QA checklist, what do you mean by lab operation related to study conduct? Can you please identify some of these? I'm not too sure about this question of where that is, lab operation. This is the QA list. Does that mean somewhere here? Lab operation typically is those lab activities and related to study. Of course, this is all related to the study. Okay. Amar, I will send you an email. Make sure it's Amar. Oh, no, I'm sorry, Dr. Farah. I'll send an email. I will ask detailed questions. Maybe I can understand the detail exactly what I understand it before I can answer you. Okay, pass rate, that causes the interfere. It's possible. This is the same thing as a plastic thing. It's possible, but wouldn't be too much for our purpose, for the pesticides. It's possible, yes. Okay, sometimes this appear to be GCMs. Yes, it's possible. Okay. Okay. Okay, general number 5 at A. General number 5, this one. Oh, okay. Okay, I understand now. That means all your lab-related work, do you have an SOP to follow? So you do all the lab, for example, the easy one, like centrifuging, do you have SOP to handle that? Do you follow that? And sometimes, well, if the bigger piece, you may have something. So that means that's the activity, that's the operation. So all the lab activity needs to follow your SOP. So do you have a SOP to follow? So that means it's going back to SOP. So you should have an SOP to follow. You do, for example, you do the SPE. Do you have the SOP for SPE, or you follow the method? Sometimes the method will give you the details. So this is what it means. So if you work in the lab, you pretty much know the SOP for that. How you use the centrifuge, how you use the vortex, how you use the turbo vap, and all those things. How you grind your sample, if you use like a high-speed blender, tissue miser, or you use the shaker, something. So this is all lab activity. So you need to have an SOP for those activities. Okay, I think that's a good session. Good questions. Okay, if there's no question, and yeah, have good evening there, and see you tomorrow, same time. Good. Thank you.
All right. Many thanks to everybody, to Wayne for his great presentations and all the time in the preparation. Thank you for your participation and for your attention. And again, also thanks to all the people in the background helping with the IT so that we don't have a lot of, not too much background noise, right? Analytical
Actually, it's
chemists
good.
don't like background noise.
Good.
All right. Thank you very much. And see you tomorrow.
Thank you. Have a good evening.